Go outside tonight. Find Orion. Look at his right shoulder. That orange-red star. That's Betelgeuse. And I want to tell you something about it that'll quietly mess with your head every single time you look at the sky from this moment forward. That light hitting your eyes right now, it left that star 700 years ago. What Betelgeuse looks like tonight, you can't see it. Nobody can, because by the time its light crosses the gap between there and here, the star itself could already be gone. This is the story of the most watched explosion that hasn't happened yet. A star 700 times wider than our sun, a nuclear engine that's been burning for 8 million years, and a collapse so violent, so incomprehensibly fast, that it will release more energy in 10 seconds than our sun will produce in its entire life. Here's something to sit with for a second. For all of recorded human history, for every single night our species has existed on this planet, people have looked up at Orion. Ancient Egyptians saw it as Osiris, god of death and rebirth. The Mayans tracked it to mark harvests and seasons. Sailors steered entire ships by it, crossing oceans in the dark. And that orange star at Orion's shoulder, Betelgeuse, was there for all of it, every single night. What those civilizations couldn't have known is what that star actually is. It's not just a dot of light, it's a monster. Think about our sun for a second. It's so massive, it holds 99.86% of everything in our solar system. Every planet, every moon, every rock and grain of dust, all of it, barely more than a rounding error. You could fit 1.3 million Earths inside the sun. That number probably doesn't fully register. That's okay, it shouldn't. Now, imagine swapping our sun out, Celeste, and dropping Betelgeuse in its place. Mercury gone, Venus gone, Earth gone, Mars swallowed, the asteroid belt vaporized inside it. Jupiter, a planet so large you could fit 1,300 Earths inside it, absorbed, and Saturn would just barely graze the surface. Think about where you're standing right now. Betelgeuse is what's called a red supergiant. There aren't many of them. And that's not an accident. Stars like this don't get to stick around. Our sun will burn steadily for about 10 billion years. Betelgeuse, it's only 8 million years old, and it's already falling apart. If the sun's entire lifespan were a human life, 80 years, Betelgeuse would be a mayfly. It would live for 3 days. 3 days of burning so furiously, so recklessly, that even from 700 light years away, no telescope, no equipment, just you standing barefoot in your backyard, you can see it glowing, one of the 10 brightest stars in the entire night sky, with your naked eye. But in late 2019, something happened. Something quiet at first, then impossible to ignore. And it sent the astronomy world into a very controlled, very professional kind of panic. December 2019, amateur astronomers comparing notes online. Something's off. Betelgeuse is getting dimmer. Now, Betelgeuse does this naturally, to a degree. It pulses like a slow heartbeat. Every 400 days or so, it swells and dims on a predictable cycle. Astronomers knew this. They'd been tracking it for over 200 years. Variable star, normal behavior. But this wasn't that. By February 2020, Betelgeuse had lost more than 60% of its visible brightness. In 200 years of observations, through wars, through the invention of photography, through the space age, no one had seen it do this. And the question that nobody in the scientific community wanted to be the first to say out loud, is this it? Is Betelgeuse about to go? Because here's what makes that question terrifying rather than just interesting. Massive stars don't quietly pass away. In the years, sometimes decades, before a supergiant collapses, astronomers believe it enters a phase of instability, dramatic brightness swings, unusual mass ejections, a kind of final restlessness before the end. And what they were watching with Betelgeuse fit every single symptom. Here's a number that'll help you understand the stakes. The last supernova visible to the naked eye was in 1987. We called it SN 1987A. It was 168,000 light years away, a distant spark gone in weeks. Betelgeuse is 700 light years away. That is 240 times closer than SN 1987A. If Betelgeuse goes supernova, we would not see a distant pinprick. We'd see something that would rewrite how every human being on Earth experiences the night sky, possibly for years. So every major telescope on the planet slung toward Orion. Professional observatories in Chile, Hawaii, Arizona, Spain, amateurs with backyard rigs, graduate students losing sleep, all watching the same star, all waiting. And what they found was not what anyone expected. Hubble was on it. The very large telescope in Chile, one of the most powerful instruments humans have ever built, locked onto Betelgeuse and just stared. And the data that came back was genuinely strange. Betelgeuse wasn't dimming uniformly. Its southern half, Slask, was dramatically darker than the northern half. That's not how a dying star is supposed to cool. That's not symmetrical. That's not clean. Something specific had happened in one region of this star. Two theories showed up almost immediately. Theory 1, a massive star spot, like sunspots on our sun, regions of cooler, magnetically suppressed plasma. Our sun gets them too, but a sunspot on Betelgeuse at that scale would have been larger than Jupiter. An entire planet, just a blemish. Theory 2 was wilder, and it turned out to be correct. Betelgeuse had sneezed. I'm not being cute. That's genuinely the closest analogy. Months before the dimming started, Betelgeuse had launched a bubble of superheated plasma off its own surface. Not a small bubble. A bubble with a surface area several times larger than our sun. This thing rose from the star, punched out into space, and started cooling. And as it cooled, it turned to dust. A slow-forming dust cloud drifting just beyond Betelgeuse, sitting between us and the star, eating its light. Scientists called it a surface mass ejection, the largest ever recorded on any star. The amount of material Betelgeuse blew off in that one event was hundreds of millions of times greater than the biggest eruption we've ever seen from our sun. Hundreds of millions of times. By mid-2020, the dust cleared. Betelgeuse stabilized. It went back to its normal self, blazing orange in Orion's shoulder, like nothing had happened. The world exhaled. Some people were relieved. Some were a little disappointed. You know who you are. But, and this is the part people skipped past, the great dimming hadn't told us Betelgeuse was fine. It had told us something was wrong in a way we'd never seen before. In the years after, astronomers rebuilt their models from scratch. New measurements of Betelgeuse's mass, its age, its core temperature, and the quiet conclusion they landed on. Betelgeuse is further along than we thought. Not going this week, not this century, but in the span of cosmic time, the next 100,000 years, this star explodes. 100,000 years. That sounds like forever, but remember what I told you in the first 30 seconds of this video. Betelgeuse is 700 light years away. The light leaving it right now won't reach us until the year 2726. The explosion could have already started right now as you watch this, and we won't know for centuries. To understand what happens when Betelgeuse actually collapses, what it really looks like, moment by moment, you need to spend a few minutes inside it. Fair warning, it's a lot. At its core, a star is a war. Two forces, opposite directions, neither willing to quit. On one side, gravity, always pulling inward, always trying to crush the star down to a point. On the other, nuclear fusion, pushing back, releasing energy so powerful it holds the entire star up against gravity's pull. Our sun fights this war with hydrogen. Simple, efficient. It's been doing it for 4.6 billion years and will keep doing it for 5 billion more. Hydrogen is an incredible fuel. Betelgeuse burned through all of its hydrogen a long time ago, and then it moved on to the next thing. That's the thing about massive stars. When they run out of one fuel, they don't die. Not yet. They pivot. Helium, burn it. Carbon, burn it. Neon, gone. Oxygen, gone. Silicon, each new fuel burns faster than the last. Each one releases less energy than the one before. The star is getting more desperate, not more powerful. And right now, at the very center of Betelgeuse, silicon is being fused into iron. That's where the road ends, because iron is different. You cannot fuse iron and get energy out of it. Iron doesn't give, it only takes. It absorbs energy instead of releasing it. So while the outer shells of Betelgeuse are still burning, still pushing outward, still holding up the star, the iron core just sits there, silently accumulating, getting heavier, getting denser, like a countdown with no clock. There's a limit to how heavy that iron core can get. Scientists call it the Chandrasekhar Limit, roughly 1.4 times the mass of our sun. When the iron core hits that number, gravity wins, instantly. The core has been building for years, quietly, inevitably. It reaches the limit, and in less than a quarter of a second, it collapses. Not slowly, not over years or centuries. A quarter of a second. The iron core, roughly the size of our planet, implodes. It goes from Earth-sized to 20 kilometers across. 20 kilometers, the size of a city. The mass of 1.4 suns squeezed into something smaller than the distance you can drive in 10 minutes. The density at this point is beyond any analogy. A teaspoon of this material would weigh 1 billion tons. If you could somehow drop a sugar cube of it onto Earth's surface right now, it would punch through the crust like it wasn't there, sink to the center of the planet, and then just oscillate back and forth through the Earth like a marble in a bowl forever. Okay, not in theory, not in approximation. What happens second by second in the final moments of Betelgeuse? The silicon in the core has been producing iron at a terrifying rate. The core reaches the limit, and then, on 0.25 seconds, it's over. The outer layers of Betelgeuse don't even know it's happened yet. Information, even in physics, can only travel at the speed of light. And the star is so enormous that the outer layers are still holding themselves up against a core that no longer exists. They're standing on nothing. They just don't know it yet. Then the bounce. The core gets so dense that the fundamental forces between subatomic particles, the strong nuclear force, refuses to compress further. The core hits maximum density and bounces back like a cosmic spring, releasing 8 million years of compression in a fraction of a second. A shock wave explodes outward from the center. But, and this is the part that blew physicists' minds when they first modeled it, the shock wave isn't strong enough, not on its own. As it tears through the dense stellar material above the core, it starts to slow, it stalls, the star just hangs there in this impossible moment between alive and dead. And then something saves it, something almost miraculous: neutrinos. During the core collapse, protons and electrons are smashed together under impossible pressure. They merge, they become neutrons, and in that process, they release a flood of neutrinos. Now, neutrinos are the most antisocial particles in the universe. They pass through everything, walls, lead the entire planet Earth. Right now, 100 billion neutrinos are passing through every square centimeter of your body every second from our sun, and you feel nothing. In the core collapse of Betelgeuse, the neutrino burst produced in just those few seconds will carry more energy than our sun will radiate in its entire 10 billion year lifetime. Think about that sentence. Not 10 billion years of energy stored in Betelgeuse, more energy than our sun produces across its entire existence, released in seconds. And because the collapsing core is so insanely dense, even the ghost-like neutrinos get partially trapped. Just 1% of their energy transfers to the stalled shockwave. 1%. That's enough. The shockwave, now turbocharged, tears through every layer of Betelgeuse at a significant fraction of the speed of light, ripping through oxygen, carbon, helium, hydrogen, and as it does, the temperatures and pressures become so extreme that new elements are forged in milliseconds. Gold, silver, uranium, things your wedding ring might be made of, created in the death throes of a star. And then the shockwave hits the surface. For weeks, Betelgeuse will shine with the brightness of 10 billion suns. 10 billion in one star. On whatever night it is, whenever Betelgeuse's light finally makes the crossings, It will start as a brightening, just a little. Orion's shoulder seems a bit more intense than usual, then noticeably bright, then wrong bright, too bright, unnaturally bright. Within days, Betelgeuse will rival the full moon. You could stand outside at noon on a clear day and see a second light blazing in the sky. Not a planet, not a plane, a dead star, 700 light years away, outshining everything but the sun itself. At night, it would cast shadows, actual, crisp, definable shadows on the ground, not from streetlights, not from the moon, from a stellar explosion that happened 700 years ago in a galaxy we barely understand. It would last for weeks, maybe months, and then, slowly, gradually, it would dim. And Orion would never look the same. The right shoulder empty, the constellation our ancestors mapped and named and navigated by for 50,000 years changed permanently. But here's what I want you to hold on to. This is not a story about loss. At the center of that explosion, that collapsed core becomes a neutron star, spinning hundreds of times per second, sending out beams of radiation like a lighthouse sweeping through deep space. A pulsar, one of the most exotic objects in the universe, born from Betelgeuse. And the cloud of material Betelgeuse scatters into space, will drift outward for thousands of years, carrying with it every element this star ever made. The iron in your blood, it came from a star. The calcium in your bones, a star made that. The oxygen in your lungs, right now, in this breath, forged in the heart of something that burned and died before our solar system existed. Next time you look up at Orion, don't see a pattern, see a story. Betelgeuse isn't a dot of light on a star chart. It's a nuclear furnace that was already ancient when the pyramids were new. It's a sphere of plasma 700 times wider than the sun. It's a dying star in the middle of a process that's been running for 8 million years and will end in the most spectacular way the universe knows how. And this is the part that gets me every time. Every element heavier than hydrogen in the universe was made inside a star, not as a metaphor, not poetically, physically, literally, in a nuclear furnace that then exploded and scattered itself across the galaxy. The iron in your blood was made in the core of a star that died before the Earth existed. You are looking at your ancestors when you look at the night sky. And when Betelgeuse finally goes, some of what it becomes will drift for millions of years. And eventually, somewhere, it will become a planet, maybe an ocean, maybe a life. Carl Sagan said, "We are made of star stuff." He was right, but I think he could have gone even further. We aren't just made of star stuff. We are the universe, figuring out how to look at itself, and when Betelgeuse finally collapses, we'll be there, watching, understanding, awestruck, just like every human being who ever stood under this sky before us. Betelgeuse was burning before Rome fell, before the Crusades, before anyone reading this had great-grandparents. And tonight, if you go outside and find Orion, it'll still be there. So actually do that. Pause this, go outside, find that orange star on the right shoulder, and just sit with what you now know about it.